Good afternoon, Scott here, known as Cantaloupe to some online, and I'm bringing another video to you on a subject that's interesting to me. It might be of interest to you or someone you know, and that is biases. A few different kinds of biases that are common and pretty dangerous to people. And I want to just go over some of the well-known ones and also some that may not be super well-known in a few minutes or less. So I'm going to get started, jump right in. The first one is confirmation bias. That's when your experiences and familiarity with something create a bias towards what you already know, what you've already decided or concluded or confirmed, hence the name. And it's a type of bias that is natural and normal for people, especially because we depend on memory for efficiency. It's easier to remember things that we have learned already rather than have to process something from scratch every time. So one pitfall from the convenience of having memory is that we are biased towards the things that we have already confirmed in the past. So that's one type of bias. Another kind is that I recently learned myself is survivorship bias, and that is, for example, like in World War II, there were these fighter jets or planes that would come back with bullet holes in them, and they would use the location of the bullet holes for data to decide where to put armor, extra armor, beef up the armor. And the problem here, survivorship bias, is that that's not where the armor should go. Ideally, it's because the planes where the bullet holes took down the planes didn't actually make it back. So, in the areas where there's a cockpit or an engine strike with the bullet, those planes never made it back. So you don't get that data, and that's called survivorship bias. It's another powerful kind that can influence and affect your analysis or data collection if you're doing that kind of thing. I also want to point out another kind of bias that's really common and dangerous right now, and that is pairing of ideas, where you have two things presented together, and it's natural for people to link them mentally, especially if it's presented in a repeated way over time. Unfortunately, there's a lot of unscrupulous people who have learned to use this technique to open wallets and get people to believe things that aren't necessarily true, or to associate things, and thereby on a large scale, when it's rolled out over time, it can influence behavior and shift perspectives and get people to buy things and all kinds of nasty stuff that they wouldn't necessarily do. It's not nasty to buy things, but if they weren't planning on it, if it's not something they need, using psychology to open their wallet is pretty unscrupulous, I think. And that leads me to the fourth and final bias I want to mention in this video, and that is what I call non-random bias. And this might be a new idea, I'm not sure. Non-random bias is chance and the exclusion of chance in scientific testing or analysis. Let me explain. So in order to test something in a laboratory or in any kind of hypothetical situation where it's not an actual situation, it's hypothetical, you have to create an artificial environment, and then you make things happen. You push things in one direction or another so that you say, well, this could happen or that could happen, and then you observe and take measurements or record your findings. That's science. That's part of the scientific process. Unfortunately, these artificial environments are always missing something very important, and I want to talk about that a little bit. So, chance, and there's a debate, not so much a debate, but a refusal to acknowledge determinism, or not, I should say non-determinism. And let me go over that just real quick. I'll connect this track back in just a second. Non-determinism has been attacked by the current administration. The people, the philosophical people, the leaders and thinkers of modern times have decided that non-determinism is not so much a thing, because given an initial state, everything unfolds the same way. And they believe, I think they believe, and they are trying to lead others to believe, that we live in a very deterministic universe where everything is already decided in advance, and it's just not true. And if you understand what determinism is, it's a question of boundaries. It's all about boundaries, actually. So if you're within a universe, within an event horizon, you have influence over your timeline, you have influence over your immediate environment. You can make choices because it's deterministic relative to your position inside that system. For somebody outside the system, outside of an event horizon where, you know, a system can be, they're not affected by time or bound by it, they can pause the system or reboot it. Like we learn about this in computer science with virtual machines and whatnot. Determinism versus non-determinism. So you have non-determinism within, if you are within the system, and determinism potentially if you are outside of it, where you can replay something exactly how it was the last time and you know exactly what's going to happen in the future, that kind of thing. But unfortunately, you know, this isn't a digression, it's relevant. These thinkers have made the mistake of thinking that everything is deterministic, and that depends on having an initial state. I don't believe we have one of those. I believe that we live in a largely deterministic circular network, if nothing else. And that's a separate video. But to connect this back finally, chance exists. All this was to support the statement that chance is a real thing, and therefore it should be included as a variable in analysis, and it frequently is not. This is the bias I'm speaking of. To connect it finally back to the ultimate topic of this video, bias tests and analysis should include the possibility of something not happening, which is actually very likely. Instead of, you know, forcing it one way or the other, saying this could happen or that could happen, that does not mean that it will or would happen. It actually, things don't happen until they happen, and hypothetical scenarios, predictive technology and algorithms and analysis, they fail to include most times the element of the unknown, so that the data can be quote unquote as dependable and as accurate as possible. Because when you include the unknown, it becomes more realistic, but it becomes less certain. People like to deliver certain results. If it's your job to analyze data and make predictions, you don't want to deliver uncertain results because it sounds bad. It makes it sound like you don't know what you're doing, but that's the only honest answer. You know, not knowing what's going to happen is the honest answer most of the time. So this is the bias. I'm almost at 8 minutes. If you have questions or thoughts about this, I think it's a huge idea that chance being excluded from most experimentation and analysis is a problem right now, because it skews results. People say this could have happened, and so they say we might as well just assume that it did or will, but that's just not accurate. It's not fair, it's not accurate, and it affects people. So reach out with questions or comments to whitehotrobot@gmail.com. Thank you.